All right, so welcome to the Tech Basement, episode 2. I'm Matt Zielinski, and with me,
Dean Jackson,
my co-host. Welcome to our second session. Now, we're not in the Tech Basement today, Dean.
No, we're in a real live place, office, I guess.
Just due to scheduling reasons, we decided to come up to Sydney and interview our special guest that we have on the show today, Cory Minton. Cory, welcome to the show.
Thank you very much. Appreciate it.
Cory, they call you the bearded big data guy. Can't imagine where they get that from.
Yeah, the big data beard. It's one of those things that it's like credibility. You know, if you want to talk about Linux, you probably need a ponytail. So if you want to talk about big data, you need a beard.
Yeah, great. And you write a blog.
I do. It's bigdatabeard.com. It's pretty creative, to be honest, right? It wasn't a domain that was already taken, which was convenient. I didn't have to pay anybody for it. Yeah, weird, right? Yeah, so it's been kind of fun. We've got all kinds of stuff up there that's been, some of it's stuff I've written for EMC previously, and some is just kind of my ramblings and things that I see in the field with some of our customers and partners. And so, it's pretty fun. It's a nice outlet to get some thoughts out there.
Now, it's been a bit quiet in the last few weeks. Have you been on a bit of holiday? You have been writing your blog?
Yeah, so I've been in Australia. This is my 6th week here. So I kind of bookended the trip. We did a week in Melbourne for work. And then my family came with me, and we did 4 weeks of vacation here. So we've been all over your beautiful country. Well, not your new home, but we've been all over the country, and it's been absolutely wonderful.
So I have to ask, what is the coolest thing you've seen in Australia?
Well, I don't know if it's cool. It was maybe the most memorable thing was we were driving on Kangaroo Island, which is just off of the coast of Adelaide, and we were driving, and it's like a wildlife reserve, right? And so we're driving this camper van, which is comical anyway, with 2 small children and my wife in this camper van, and we're driving down the road, and I'd said, oh, like there's so much wildlife here. The speed limit seemed awfully high. Like maybe I should slow down a little bit. So I slowed down from like 100 kilometers per hour down to about 70, and as soon as I got to 70, this giant kangaroo comes running, like hopping across the street in front of me. And it was one of those things where it was like, oh my gosh, they're really out here just out in the wild. I almost had one as a hood ornament, which would have not been very cool for the kangaroo, or I'm sure the camper van.
Have seen any koalas while you're here?
We have seen a bunch. We've actually gotten to do some of the koala experiences where we hold them. My son is 16 months old now, and he decided that while my wife was holding the koala, he would try to get closer to it. And when he did, he grabbed its ear. Which is apparently a no-no. Yeah. So the zookeeper came flying in to save my wife from some claws being attacked. So it's pretty funny.
Yeah, no, they can get a bit scary.
No drop bears though.
Yeah, I was going to ask you. So
you haven't run into?
Haven't seen any drop bears. Yeah, thank goodness. Yeah, I was really worried about that.
We'll keep you away from them. They hide from the tourists a little bit and pounce when they're around. So a bit of tech news this week. HP is now officially 2 companies. It's split into 2. In Australia, I know in the US, drones has been a big topic. Walmart has announced that they're going to go down the drone path. But in Australia Post is now saying they're going to follow that approach as well, deliver parcels via drones. Do you guys fly drones at all?
Yeah, I've got a little one. Actually, the funny thing about the Australian Post is they already seem much more efficient than our post anyway in the US, because in the US we have these big, very wide, kind of awkward-looking trucks that deliver the mail. Yeah. And here in Australia, you have everybody on scooters, little mopeds,
that's right.
Which is pretty funny because I saw the guy running down the street with his little, neon yellow hat that's like flapping in the wind. I'm going, that's pretty efficient mail delivery. So I don't know why they need drones. Those things get like 100 miles to the gallon.
And don't forget, there was that Canadian, the drone,
the hoverboard.
The hoverboard drone.
Oh yeah, I saw that.
Yeah, pretty cool.
All right, and other, this is a rumor, it's not confirmed, but Samsung are apparently working on an 18-inch tablet. Dean, what do you think about that?
Well, I'm not sure what I would do with an 18-inch tablet, because, I don't know, it wouldn't fit in a bag, pretty much. But huge, right? Being a fanboy, I think we'd have to wait until the Apple one comes out. So,
and if an Apple one came out,
I would have multiple of them, that's for sure.
So do you guys think this is, that could be the death of the PC when we get tablets that large? Or are you going to hang on to PCs for a while?
I really like the keyboard.
I know, it's just so ingrained, and it feels so much more productive. I've got tablets and they're fun, but there's just something about the experience of being on a machine. And frankly, they could have an 18-inch tablet with a nice big keyboard that's attachable. Maybe that makes it maybe more versatile. And I think that's what you're starting to see is those sort of hybrids, tablet, laptop kind of mixes. That I think that to me seems more interesting.
Yeah. We'll wait and see if Samsung do release that. The other bit of news, or I saw in the media the other day that the Windows 10, not that I've tried this, but they're saying that if you switch browsers, so it comes with its default Explorer browser, and you replace it for Explorer, if you switch to Chrome or Firefox, it comes up with this warning message saying, are you really sure you want to do this? Have you thought about what you're doing? As a kind of last resort, warning. Is this a good move from Microsoft, or are they getting a little bit desperate with the approach to try and keep you on their browser? Cory, what do you think?
I think it doesn't surprise me, although I think maybe it's a repeat of some stuff that they've seen in the past where they're trying to bundle everything, but clearly Apple's figured out how to bundle everything together, and they have this concept of better together. So I don't know if it's desperate. It's certainly trying to maintain their hold on the user base, which I guess the question under the covers is why do they need to do it? Is there some monetization that's going on under the covers for a browser?
And apparently it comes up with a dialogue saying, look, click here to learn more about the great features of Explorer.
Yeah.
It's kind of like you've been using it. Hang on, wait, before you go, let me tell you about how good it was. Anyway, we'll see how that works out. Now, today's topic, we're going to talk about big data. Now, there's a guy in EMC named Bill Schmarzo, who they call the Dean of Big Data.
Yeah.
Now, could we refer to you as the Dean of Big Data Infrastructure? Would that be?
It's probably a stretch. I have the utmost regard for Bill Schmarzo and his experience. I'm just a geek trying to have a little fun and tinker with some stuff hardware-wise. So anything we can do to support Bill's big ideas and the things that he's helping customers accomplish, I'm obviously a big fan of. So yeah, well, that'd be really cool. I think I'd be more like the TA of big data infrastructure.
The TA, okay. All right, we'll use that. We'll use that term in the title, the grand TA. So now in the US, some of our colleagues have a podcast called The Hot Aisle. If you haven't seen it, fantastic podcast. Now, given that they're in the US, one of the things we think will happen is we'll get guests that come out here that have already been on The Hot Aisle.
Yep.
Brent and Brian, the two guys who host it, great hosts of the show. So we've been thinking, we'll probably have to go deeper, unpeel the onion on the guests that we get to go to that next level. Now, have you been on the Hot Aisle?
I've not. See, like I said, I don't think I'm that big of a deal, right? In my head I am, but I don't think these...
So we got you first.
That's right.
Not that we're competitive.
No. Yeah.
So
the invitation hasn't come formally yet from the Hot Aisle guys.
So for Brian and Brent, if they get you, it'll be sloppy seconds. Is that a term that... Is that the use?
That is.
Sloppy
Yeah, I think it is.
So we'll get all the good stuff here, right?
Everything will be retreads. It won't be any good.
Awesome. All right. So we got there first. So let's get on to today's topic. And one of the things I saw in your blog that I was really interested in, and we've done a bit of stalking on Twitter and LinkedIn and so forth to find out more about you. We've seen the big pictures of elephants and so forth.
Yeah.
On your blog, you talk about an architecture called the lambda architecture. Could you take us through what's that all about?
Yeah, so the lambda architecture it's really a concept that came out of this gentleman named Nathan Mars, who worked at Twitter and a couple of other places. And the concept is really just that data as it comes in may have two distinct values to an organization, and there are different processing methods for dealing with data as it comes in that may be valuable to an organization. So if you think about it, that we want to get as much data as possible. Big is the volume. Or one of the V's of big data is volume, right? So we want this big volume of data. So that means we want to store lots of data, a lot of history. We want to store as much as we can. And that's where technologies like, HDFS within the Hadoop construct really start to make sense.
So that's the Hadoop file system for those?
Yeah, absolutely.
Yeah.
So the Hadoop file system is designed to be very scale out and store lots and lots of volume of data. But one of the other V's of data is this velocity concept, and that's that data can come in very quickly, and that its value is equally ephemeral. As quick as it comes in, its value needs to be derived very, very quickly. And pushing that data to some sort of a big, scale-out, distributed file system may not make sense. You really might want to process that in memory, closer to the CPU as it comes in, and then eventually write that to a persistence tier. So in the Lambda architecture, you basically have this concept of you have a speed tier, which is where I want to send data to be processed very, very quickly in memory, so I can derive value from it before that data has no value, or its value is depreciated greatly. And then there's this concept of a batch or a servicing layer, which is I really want all the data to come in, because I may eventually want to derive value from it. So I may run some sort of algorithm against it. I may do some sort of data science practice against that data. But it's historical. It may be data that I can just keep for a long period of time and use and do some joins and some views against other data sets to really derive its value.
So if you were eBay, for example, if you've got a shopper that's just bought something on eBay, you might come up with and you might also like these items. And I guess with hundreds of thousands or millions of people accessing that platform, you've got to do that very quickly.
Absolutely.
But there's obviously some intelligence that's got to come into, shoppers like you also bought this sort of thing, which comes from that historical data that you're talking about. Is that the...
Yeah, recommendation engines are a popular kind of practice for a lot of this big data conversation, and that's absolutely true, right? You want to... That's actually a great example, because in order to build a good recommendation engine that could make those very quick, real-time kind of recommendations, you have to have a bunch of history. So what data scientists need is they need lots of views of historical data to understand what buying behaviors are, to develop like personas that they can apply to people, so that then they have an algorithm that they can push to a fast tier, right? To a speed tier, where as somebody's clicks start to appear like other personas' clicks, they can make those recommendations. So you actually, in that example, you absolutely need both, because in order to make the speed tier work, you need to have done some work in that batch tier to understand and build those algorithms that a recommendation engine would be based on.
Yeah. So does that architecture define how the data gets in those tiers? So I could have the data split at source into the speed tier and the capacity tier, or actually being in the same solution move down from the speed tier. Does it matter? Or?
Yeah, there's a lot of different ways. I mean, as this ecosystem is evolving, we're starting to see multiple. So, originally there were some, a couple of years ago, there were technologies like Spring XD from Pivotal was really popular because it did a really good job of doing some in-memory processing and then writing to a persistence tier. Things like Flume and Scoop in the previous days were good at kind of taking data from different sources, bringing it in that persistence tier, but could also push it up. But now we're starting to see things like Kafka, start to become more interesting. And then also what Hortonworks did with their acquisition of NiFi, and this Hortonworks data flow product is really interesting because it's going to do exactly that. It's going to bring data from thousands of sources, what they're calling the Internet of Anything, and then absolutely do the speed tier, but also persist it down to something like an HDFS for that data science, type of team to use things like MapReduce and others to process it. So there's different schools.
Well, these buzzwords just keep changing. So we went from Internet of Things to Internet of Everything.
It's IoAT. It's another one.
Anything.
So I'm seeing some customers, like we had a customer recently, they're deploying HANA, and they're connecting it to Hadoop. So that's really sort of a lambda architecture, wouldn't it?
Absolutely, and that's sort of the funny thing about a lot of the big data conversations is a lot of times what we're trying to do with these big data technologies is take unstructured data and create some structure around it, so then I can marry it with structured data to really derive value from it. So that HANA example is great, because HANA obviously is the database that SAP's launched because they want to run all their ECC environments. All the transaction data needs to live in HANA for extreme speed, but then it also gives you incredible reporting performance, right? That's part of the value prop. But then marrying that to things like they have some native integrations to Spark that their VP of Engineering launched. It's talked about at Tech Ed, right?
Yeah,
Spark. Yeah, exactly. Talking to Spark and then using either Tachyon for distributed file system management or direct to Hadoop using the Spark plugins to actually now be able to take data and bring it into HANA, or to do joins in places like Spark to do that in-memory processing for data that maybe lives in two disparate places.
So, and on that, I mean, we often talk about these big data silos. We'll touch on that topic a little more later, but isn't this creating that fast data silo where we've got some in-memory database with its own persistence layer, and then a separate big data platform where we're constantly bringing data in and out? Is that?
Yeah, it's kind of the nature of the beast, frankly. And so I kind of draw some parallels, because although this big data stuff, the technologies we're using are new, and there's lots of new buzzwords that change every day, it seems like, the concepts aren't all that new. There's a lot of things that we've been doing for years that we're just applying at different scale than we ever did before. So think of it this way, right? The batch tier, that lower speed tier, the persistence tier, is like it's like our database, or what we used to, like, we even had this thing called master data management, right? Where we had this massive database that was the single source of the truth. Well, when you had that, what you also had was different business units or different requirements would say, well, I need a different view of that data. So you would do an export, or you would create these data marks, right, that were smaller subset views. It's kind of the same idea, where we're basically saying that, hey, we need all the data because that's what big data is. Give me all the data so I can then go choose what I want to do with it. But we know some of the data needs to be processed really, really fast. and we need to make some decisions really, really quickly. So let's put that into a separate tier. The goal, and I think as we start to see, and we're already seeing a lot of maturation in this market happen, those will become more connected to where you can do the processing here, but the consistency will be managed by an application, by software that will allow persistence to happen just natively, no matter how the data flows.
Yeah, gotcha. All right, and so one of the, I guess, topics we want to touch on today was around Splunk in this environment. Right?
Yeah.
So you build a Splunk Ninja team, I think we call it. Is that?
That's right. Well, we're not the guys who invented the Ninja the term. The actual Splunk is obviously a neat software company. They've had a cult-like following for many years, and so they're experts. The folks that are very active in their online community, helping answer questions, providing feedback to the development teams. They call them ninjas, and when you go to .conf, for their annual user conference, you'll see them walking around. They've got these really cool black hats, and I say really cool because we're in the tech garden. It's cool here. They're like a Shriner's cap. If you guys have Shriners, like the little round cap with a tassel. So they're pretty comical. And then there's another layer of ninja that has a cape. They actually have capes, which is pretty awesome. So we at EMC realized that from a pre-sales perspective, we were having a lot of conversations with customers about building massive scale Splunk environments. And there was very few people around the globe that really, at EMC, who had a really deep understanding of the infrastructure requirements to support these large scale Splunk environments and really what it meant to apply EMC technologies to this, this really burgeoning software, right? Where companies, a lot of times Splunk was starting in a small little closet use case. They'd solve a problem really elegantly with Splunk, and then all of a sudden the CTO wanted to deploy it everywhere. So now they're going, oh, now this is in the purview of IT globally. We have to deploy more enterprise systems. So basically what happened is we recognized we didn't have nearly enough folks within the SE community that were highly trained in this area to help our teams around the globe help sell and build solutions. So we got a group of, I think now with the total global population of ninjas is about 32. So we got 32 SEs globally who are part of a ninja team. And this is basically just it's kind of a side job. So if you have your day job as an SE for the core team or for Isilon, you may also get tapped to be a ninja. We basically are putting you through some pretty intensive training and some certifications so that when a customer wants to talk about Splunk and they've got their Splunk admin, we've got somebody from EMC who can sit across the table from them, speak their language, understand the technology architecture, use their vernacular to describe it, and make sure that we build systems that work and support the needs really, really well.
So do you want to take us through
an
example of a Splunk environment?
Yeah, so I'm part of this group.
It is.
Yeah. So
really
it's not your day job, but
it's
it's
not my
you
day
get
job.
to doing your
So
20% time. I think is what
Yeah.
Google
Well,
calls
Dean was kind of one of the inspirations for this for the Ninja team. So I'd started over in the U.S. fielding a lot of these conversations, getting deeper in our conversations, and when I ran into anything I didn't understand, I called Dean. So he's really the brains behind the operation. So I'm glad to have him as part of the team. I'm just the guy who got the whip cracking on these guys.
So I thought I'd do a bit of a demo here. You're talking about the lambda architecture.
Absolutely.
And wouldn't Splunk sort of be a lambda architecture, especially when connected to Hadoop?
Yeah, absolutely. And that's a great time because Splunk Enterprise does a great job of taking data from lots of sources, processing it very quickly, writing it to a persistence tier, but also give you that reporting, that alerting, that capability to build tools on top of data as it's being processed. So that's cool, and that we can have that speed tier. Splunk Enterprise does that. A couple of years ago, they launched this thing called Hunk, which we're going to talk about, right? Which is giving you the ability to use Splunk queries on top of a Hadoop environment. So actually taking that Splunk intelligence and pushing it down against data that lives in Hadoop. That's really neat, and it was kind of disconnected early on in its development, which is kind of what we're saying about that maturation. You have the speed tier, and then you have the sort of disconnected sort of model. Well, especially with their announcements they made at .conf this year with unified search, we've really now connected the two, where and it's much more elegant, and where now you have this speed tier with enterprise, you have this Hunk tier for your batch and servicing tier potentially, and you can do unified search across them. I think that's part of what Dean's going to show, but it's absolutely implementing the concepts of Lambda, just using their technologies.
Cool. So what I want to show here is basically I'm going to show Splunk Hunk 6.3, which is far more integrated in 6.3. First of all, I'm going to show how easy it is, a Federation product here, big data extensions. So deploying Hadoop within a VMware environment. But more importantly, it's very easy within this environment to deploy a Hadoop cluster. So what I've set up here very, very quickly is I can set up a cluster very easily give it a name, and I can choose my distribution. So I've added, in this case here, I've done Cloudera. So I've got Cloudera 5.3 installed in my environment, and I can go through, and instead of doing a basic Hadoop cluster, I can do a compute-only cluster. And when I do compute-only, I'm going to use an HDFS target in the back end, which is, you can see, ISON.
Yeah.
So I simply type in the URL, the HDFS URL, to the ISON array, into the field here, and connect it to the cluster. So, yep, HDFS. So
nice.
I'm not going to go right through it. So I already have it deployed here. So I have a hunk ISON cluster. So if I click on it here, see very quickly I have my workers and compute master in my cluster. So pretty cool stuff. If I go over to my Splunk environment, so now I have a running Hadoop cluster on ISON. The cool thing about ISON, before we go over to Splunk, is I can browse the ISON cluster through some other protocol. So the multi-protocol in ISON. So I can go in here, I've connected through SMB to the ISON cluster. I can go into home, user, and I'm doing everything as root here, so it's just really easy. And I have a hunk directory. In there I have some hunk data that I've simply put in there. Go over to my Splunk environment. Here's Splunk 6.3. Pretty cool stuff. Hunk is natively part of Splunk, so when I install it, Hunk is there. The only requirement for Splunk is to have the HDFS client libraries on there, so I can browse HDFS. Go in here, go to virtual indexes. So Splunk has native indexes in it. We create what's called a virtual index, which is on the ISON array. So what I can do is explore the data. So I've set up this index. I can select my provider here, which I've set up, which points to the ISON Hadoop cluster. Choose the index, go next. And what it's going to do is basically do an HDFS query down to the ISON. And there you can see the very same data that's in my ISON array that I've browsing via SMB at the very same time. If I go a little bit farther, I can select the piece of data. And what it's going to do is do a MapReduce and have a look at that data. And it's going to give me a preview of the data. So I can see everything that's within that file.
Brilliant.
Yeah, it's pretty cool stuff.
And actually one of the things I like about this is one of the things that a lot of our customers complain about is the concept of data wrangling. So really understanding what is the data telling me, where is it, how is it stored, and the fact that Splunk has a much larger user base than Hadoop does from a just deployment and pervasiveness from a software perspective. The fact that somebody who understands Splunk could easily go derive value from data and start to understand what data exists in a Hadoop cluster. That's incredibly powerful. I mean, data wrangling is one of the things that if you look at what data scientists spend most of their time doing, it's that. I mean, data wrangling, they say, is typically between 40 to 75% of the time of a data scientist.
Right, okay. And I want to show you how easy this is. So last TechBasement, we had Ned on, and he grabbed some tax data from the ATO. So I went and grabbed that very same tax data myself. He did a great demo showing, tax by postcode and all that. So I grabbed the same data. So here it is. It's just simply a CSV file, so pretty simple stuff. What I'm going to do is take that CSV file, and I'm just going to copy it straight in to the ISON cluster through SMB. It's pretty simple stuff. Everybody knows how to do that. Now it's there. Now I can go into my Splunk environment. I haven't done anything. I can go into search and reporting, and I can specify my index. My index is called Hadoop.
Great in there.
Yeah. And the cool thing about it is it's going to have a look at that index, which is that HDFS mount point. And what we're going to see is the everything that shows up in that index. So right away, there's my CSV data, right? Pretty cool stuff. And then I can start looking at the sources and source types in that index. So this is the real power of Splunk in the big data environment. But even cooler, what I'm going to do is put a little bit of visualization on it. So Ned did a great job showing the rows of data. There's a really cool new feature in Splunk called Coral Plus. I can't say the word properly. It's a type of map. So basically what I have here is the index, the source, so it's my CSV file. I'm going to send it to a function that's going to look at income per individual in that postcode. And then I'm going to send it to this geom function, which is the Coral Plus function. And what I had to do is grab Google Earth map files for the postcodes, the polygons, and bring it into Splunk. So I did all that, hit return, and it's a pretty cool search. And you can do some amazing things in Splunk with this. So here we go. We got a map. And you can see here it's built a bit of a legend here. I'm just going to change my zoom level here so I can zoom in nice and close. So good. Now I'm going to go over to Australia. I'm going to zoom in here. And I think Ned went over to Sydney when he was looking at it.
That's right. He was looking for the cities, suburbs that pay the most tax. I think was the trying to find all rebates and so forth.
I want to find out where all the rich people live.
Yeah,
well, that's pretty much what we do.
Yeah. So what I did with it is I went a little bit farther, and I created a new field that basically figured out how much the average wage was per postcode. So I'm going to zoom in here. Pretty cool stuff. You can see every single postcode in Australia, and this is from the Google Earth stuff. And we're just about done here, and I'll show you right here. I'm down Botany Bay. There we go. So this is where we were looking at before, and you can see a nice little thing here, and very, very similar types of data, but now I have a visual view of it. So you can see here postcode 2027, is that Rose Bay, I would think, maybe? Average income, $177,000 per year. Obviously, a fairly affluent.
Are they hiring in that?
Yeah. So pretty cool stuff. So great example of taking Hadoop data, very quickly putting data into Hadoop data, which is sitting on Isilon. So you don't have to do any ETL or anything like that, and then pointing Splunk at it, and then giving visualization of it. Very quick.
So I think, and just touching on a comment you made earlier, Cory. 2-3 years ago, there was this big kind of media frenzy over data science is the sexiest job of the 21st century, but we don't have enough, right? We're not when you start to look at some of these tools like Splunk, I guess you've put you're not a data scientist, you've been able to pull this together, right? And all the algorithms, the intelligence is built in and simplified. So are we starting to get to a world where maybe the data science isn't the most important thing, but understanding the data and the business outcome is?
Well, I think that's actually what the data scientist's pure function is really, connect the dots. It's not necessarily just the ability to go in and manipulate the data and wrangle the data. I think that there's, we in general at EMC and in our consulting organization, we have this model that we really believe that data science is a team sport. And yes, you absolutely need data scientists. Yes, that job is really cool. And it's, I think what we need to see it do is have data scientists do the really advanced work. I think with software development that we're seeing from companies like Splunk, we have smart DBAs and analysts and people that understand databases that can use tools, or even that have experience using Splunk for network monitoring or threat detection, right? That can apply those same skill sets to a broader set of business problems and can do a couple of things. One, leverage the skills they already have and the technologies, understand that use the technologies they already know to solve new problems. And frankly, that's one of the most exciting things we're seeing for a lot of our customers is Splunk administrators are now being tapped to go solve different problems. And so it's the same old adage, right? If I have a data scientist and he has, a list of 1,000 things that the business wants to accomplish, if 3 or 4 of them are really advanced, revenue generating, powerful projects that may take, months for a data scientist level person to solve, what am I going to do with those 997 other projects? Well, why not use technologies like this, use people that I already have in my organization to solve the problem, and frankly, for our customers and for even EMCers out there that want to up their game and up their level of relevance, is to understand how these technologies can be used to solve real problems. I mean, frankly, we've got this, this Splunk Ninja team. There's already talk about how we might use Splunk to go monitor and better monitor our hardware in the field to give our customers a better experience and to give our SCs a better experience doing their job of helping keep our customers happy by keeping our gear, our clusters, our hardware, and everything up and running well. So I think it's just I think it's a team sport. I think we still need data scientists. We still need more of them. Frankly, the definition for a data scientist is pretty stiff. I think a lot of people kind of call themselves that, and they're not really ones. I certainly am not. I don't have a PhD in any sort of mathematics, so I wouldn't dare say I am. But I think that we need more folks just to become more data driven, and I think the software and the market, as we're seeing it evolve, is really allowing that.
I heard a journalist say, if you're a statistician and you want a 20K pay increase, call yourself a data scientist.
Yeah, absolutely. Yeah, that's true.
So now, you talked about the data wrangling as being a challenge, right? But obviously, before you can wrangle any data, you've got to get to the data. And one of the big business challenges I hear from organizations when I talk to business people is they say, IT has my data somewhere, I just can't get to it. That data silo problem or the ability to share data is a challenge. In this demo, Dean, we were using Isilon as the platform underneath the technology. There was a great article about, I think, 2013. The title was Never Ever Do This to Hadoop, right? And the gentleman who wrote it, Andrew, let's see his name, here. I'm missing Andrew C. Oliver.
Okay.
Had a great point. He said, Hadoop in the way it's architected, where we need to keep the data and the compute close together, isn't a great fit for external storage. And he referenced both SAN and NAS. And he talked about projects and environments where people had started building Hadoop environments on external storage, and the environment just didn't scale, or problems were encountered.
Yep.
And he argued that the direct attached storage was the right model for Hadoop. And when you think about the scale-out nature of Hadoop, you kind of go, well, he's got a point. Right? So why would we use Isilon, and do we not suffer that same challenge that SAN and NAS faces in the Hadoop world?
Yeah, we actually get asked the question a lot. You're right. The customers are always the ones that kind of poke on us because they're like, and sometimes it comes from the Hadoop vendors or consultants that have been doing Hadoop for 3, 4, 5 years. Frankly, Hadoop hasn't been around that long, so there's not that many people with lots of experience. Pardon me. The thing that we're hearing is that people, like you said, start down the SAN or NAS path and then it doesn't scale because those are not typically scale-out technologies. So the point of that article, I would say, yeah, it's generally right. Putting Hadoop on some sort of scale-up technology like SAN or traditional NAS, pretty bad idea. But there's a big caveat to that, and that is, and I think even that article mentions it, that eventually you're going to start to see technologies that will change kind of the scope and opinion of that article. And it's one that actually we heard from Woody Christie, who runs the partner validation lab at Cloudera, when we attended Cloudera Tech Summit this July. So one of the things that they did was they had this session at the Tech Summit about virtualizing Hadoop and shared storage for Hadoop, and it was called like the truth and nothing but the truth. So so the EMC folks, we all showed up and we expected, oh man, they're going to annihilate us. They're going to say everything that we don't want customers to hear, which is never do this to Hadoop, right? Basically the premise of that article. And it was interesting because a lot of the presentation, he said that. He said, SAN is great for your test dev prod, kind of getting things going. Virtualization is kind of good for test dev prod. NAS is kind of the same thing as SAN, right? They're scale up, so just don't do it for production on large scale. But what's interesting is on his slides, they had these commentary, right, about SAN's bad, NAS is bad. There's this big blue asterisk, and it said, this does not apply when talking about EMC's Isilon product. And that sparked a ton of conversation. So there's about 110 people in this room, and people started asking questions like, what do you mean? What is this Isilon thing you're talking about? And they said, well, we brought this into our lab, and we've realized that although it is a NAS, it implements HDFS completely differently than anything that we've seen before. And it is a scale-out architecture that aligns to the same processing model that we have in a traditional Hadoop approach. So it's kind of interesting to hear Cloudera validate and say, hey, we agree that SAN, the premise of this article, SAN and NAS are bad, but Isilon does it differently, and it is because we do it as a protocol. We're scale-out in nature. And that article was also, even in 2013, 10 gig networks were not the norm. Having customers run 100 plus Hadoop clusters was not the norm. Really, the only folks, at that 2013 that were really running a lot of Hadoop were your Web 2.0 companies, Yahoo, Google's, well, Google obviously, they've run it for 12 years. But it was the folks that were kind of in that early adopter stage. 10 gig networks weren't the norm, and big clusters weren't the norm. Well, now what we've seen is there's a bunch of studies even done by folks like UC Berkeley's AMP Lab, where they're studying large-scale Hadoop clusters, and they're finding that the premise of data locality is basically irrelevant in large-scale clusters. And then you think about it, right? I've got this concept of a file system that I'm going to spread petabytes of data across thousands of servers. So if I want to process a gigabyte of data, or let's say a couple hundred meg of data, and I've got a 1,000 node cluster, and I only have 3 copies of that 100 meg file on any particular, so of my 1,000 node cluster, only 3 servers have a copy of that data. What's the likelihood that my task tracker is going to kick off the job to actually process the data on one of the 3 clusters, or 3 nodes where that data actually lives? It's almost 0. And actually there's a lot of, if you type in Google data locality is irrelevant in Hadoop, you'll find lots of articles about it. Because the reality is at large scale, locality doesn't matter. You're not actually storing the data on those local disks where the job is actually typically being processed. And there's caveats to this, right? There's people that believe that it is. My argument, though, is that if I have a scale-out storage approach, like Isilon, that I can process data, I can store data really, really broad and really wide, large amounts of data that's not just for Hadoop, but now I've got a 10 gig connection to any particular server within that Hadoop compute cluster. I'm pretty sure an intelligent storage subsystem like Isilon with intelligent storage prefetching and caching 10 gig networks to a server network, right? I'm pretty sure I can produce more bandwidth by that 10 gig network and that intelligent subsystem to any one particular server than the 8 or 12 or 20 disks that might be local to that server. So that data locality thing becomes even more relevant. So what, obviously we get into these arguments a lot, and customers, they go, yeah, well, show me the results. And I even had this conversation with Cloudera's, some of their engineering leadership, and they're like, we don't really believe you, right? We haven't seen this, and so they're testing and they're finding that's true. And we've done a bunch of the TerraSort and TerraGen tests to show it, but it's just a different model. The flip side of it is, that's just pure processing. It doesn't even talk about the thing that we started with, which is data wrangling and data movement, right?
So I think, because the debate's really around performance, right? That's where this article was squarely focused. And I know at EMC World, I think we announced this back in May, 700 customers now using Hadoop file system with Isilon, right? So obviously we would have grown by then. I think it's a business that's growing at 150% per annum. But to get to that scale of customers, and these are all large, right? I think people deploy Isilon because they need petabytes, or in some cases we've seen tens of petabytes of Hadoop type implementation. So we're getting to large scale. But the value isn't around maintaining performance with stats, right? There's something to it.
Yeah, there's a couple things. And the things that we always hammer back to is we try to keep it really simple, right? Performance is fine, right? Pure processing performance, we'll go toe to toe, we'll bake it off. We've done it in large scale. That's great. What about the real life cycle of a project around data science? And that's the point of getting the data from some source and bringing it into my environment to where I can then process against it. But then once I process it, where do I get my results and how quickly can I get access to them? So when we start to look at that overall life cycle, having that data lake concept is really interesting. The other is, we don't think, and I don't think anybody in the market believes that there is going to be one distribution or one version of Hadoop that will rule them all, right? By the way, Lord of the Rings is one of my favorites. I didn't talk about. No, but so we kind of liken it to the database days, right? Remember when late '80s, early '90s, when Oracle was in its heyday? Oracle would come in and say, Oracle's the only database you ever need for any application in the business. It's all you ever need. You'd have these big sun boxes in every corner running a big Oracle database for all the business apps. And then what happened, right? Somebody came in and said, well, I have this new app that I want to run, and it runs on SQL. Or I have this old legacy app that runs on DB2, and then you end up with multiple distributions of databases, right? So the same thing's sort of happening in Hadoop, that companies are bringing it in and they're saying, well, I need Hortonworks for this, I need Cloudera for this, I need 3 different versions of Cloudera for test dev QA, for my landscapes. Isilon abstracts all that, right? By having the data in a single extensible file system that can be viewed by and leveraged by Cloudera, Hortonworks, IBM Big Insights, Pivotal, and by the way, Splunk via NFS or SNB on your Mac you've just shown here, right? That you can have that data easily moved. That's the game changer. That's where people start.
And also adding in VMware on this, right? So if you want to leverage those resources, have non-prod Hadoop environments and not dedicate hardware, big data extensions.
Yeah, it's it comes back to we're doing the same thing. What made EMC really a powerhouse in the '90s was we took a look at the world of data and we said, can we allow an application and its underlying database to still solve the problem that whatever business unit brought it in for is solving, but can we do a better job of storing the data? And so what we did is we came into data centers and we'd go, you got those 3 sub boxes, what are they running? They're all running Oracle. You got this mainframe over here, what's it running? It's running my DB2 environment for this legacy system. One of those new fancy pants x86 servers doing over there you got, right? They're running some new Microsoft application. Okay, we'd go in and we'd go, okay, we'll take all those, put it in one SAN, and add, compliant retention, do good data governance, snapshots, replication, all the things that make data kind of persistent. We could add all that to it, excuse me, without breaking the model of what are we trying to accomplish in business. Same thing's true with Isilon. It's literally we're saying, okay, you've got all these things that you want to do with data. Let's put it in a single place, enforce enterprise standards like good data protection, good authentication and access control, good compliant retention, those sorts of things. Enforce all the enterprise IT requirements, but yet still let the business units solve whatever problem they want without locking their data into silos that can't be shared.
Right? Yeah. Okay, so and I guess the fundamental thing, and I've seen businesses, particularly banks in Australia, do this, right? They've got a Teradata appliance, so they build a Teradata Astra appliance to sit alongside that, which is really to drive down costs of the Teradata environment. They've got an Oracle data warehouse, so they build an Oracle big data appliance next to that, again, to drive down the cost of the Oracle environment. But I guess what you're talking about, this data lake concept, is around making the environment, treat your data as a pool of information that anything can access. And I guess that that breaks down the big data silo. Is that?
Yeah, it's just a different approach, because what we're saying is that the data shouldn't be necessarily owned by the particular application where it was either created by some transaction processing or by whatever ETL process put it into that one particular location. We think data, within an enterprise construct ought to have some data management, but it ought to be accessible to more than one application. And creating silos, one, is really inefficient, right? If you think about it, if you have 5 different Hadoop clusters or Hadoop environments running, I mean, how much you pay for power and cooling in a data center to run all these different things, right? Not to mention, how many copies of the same data do you have spread between these different environments? That's the reason why the data lake concept has been so widely accepted, and why the analysts really like that concept. Regardless of what storage is with the covers or what substrate you use, data lakes make sense because we put the data, because data is big. It's the big thing. It's the monolithic thing. Like trying to move a petabyte of data across 10 gig networks is going to be painful. So don't move it as much. Pick what data you need out of the data lake, process it, or process it in place as much as possible, and let the application still, like the business unit, still solve the problems they want without creating silos, barriers, inefficiency, and frankly, governance problems that come with this large amount of data we're creating. So yeah, it's what we're trying to break is, hey, if you've got an Oracle, EDW environment running on, their Exalytics platform, great. Does it support some sort of a backup or an archive to NFS? Maybe. Does it have direct ties to HDFS? Yeah, they use under the covers, they use Scoop. Great, we're HDFS. Use us as your data lake tier for persistence, continue to derive value from that Oracle asset, and then if you have a Teradata appliance, Teradata has been making acquisitions like crazy over the last 18 months in the Hadoop space because they recognize that their customers were going to go make Hadoop decisions regardless of what Teradata was doing because the cost of the Teradata appliances was so high. So why not embrace it? And that's exactly what Teradata is doing with Aster and others. They're trying to play nicely to give their customers flexibility and choice. We're just saying, hey, we're a really nice substrate tier that still allows Aster to do its really cool data integration things, simplifies the data management and storage practice.
So Cory, I'm conscious we're nearly at the end of time. It's been an absolute pleasure to have you on the show today.
Cool, thank you.
Now, one of the things I did want to ask, with that beard, the kind of the hipster idea, you look like you were born for IT. As a kid, were you a coder? Did you play games?
No, so funny enough, so my family actually, we owned an IT consulting business. My dad was a really early COBOL and DB2 developer. Ran a consulting business that trained a lot of big organizations on how to do development in COBOL and DB2. So I knew what an LPAR was before LPARs were cool, which became what basically VMware is, right? As a logical parameter. So I didn't do a lot of coding. I was more of a hardware geek. So from a computer perspective, I remember early on my dad got one of the first compact 286 portables, which was like a 50-pound. Like the keyboard folded out of it was insane, but I played Wheel of Fortune on it, and it was amazing. But I was more of a geek for remote control cars, and I did a lot of more kind of technical engineering stuff. I used to hot rod RC cars just by jumping up voltages and amps and blowing all kinds of things up. So yeah, that was kind of my background was more on the hardware side. So I spent some time in my career in the software game, and I finally came home to hardware.
Awesome. Well, and I guess it's much more than hardware, right? Big data, it's
absolutely.
A whole practice behind it, the software, there's hardware.
Yeah, I really like the concept of being a company that we sell these big, beautiful, boxes that have flashing lights on them, but all under the covers is just software that's really smart and that makes it really cool. So it's kind of a fun mix.
And interesting, we're implementing right now in a cloud environment an Isilon platform for a big data as a service cloud platform.
Yep.
So we're seeing our technology, I guess, not just be deployed in the data center, but deployed as a cloud platform.
Yeah.
These cloud providers are realizing the value of the story you just talked through, of breaking down the big data silo and bringing all your structured and unstructured data together into a platform.
Yeah, and you guys ought to be excited. Hopefully there's a lot of press going on here about the big launch on November 10th for Isilon.
There is. There's a big party happening.
Yeah.
It'll be huge.
That's right. We're very excited about it. So actually for your cloud providers, for your customers looking to further break down the barriers between the edge, the core, and the cloud, to simplify that experience, to extend the analytics framework outside of just your traditional kind of constructs. It's going to be a very exciting launch that we're, I think the whole engineering team at Isilon is super excited about.
It's a great preview. Have you given away a few secrets there of what's coming?
No, everything there's it's all been cleared by press, so I think
we were hoping we would unhinge a few of the secrets.
Secret.
No, I think there's somebody around here that might, if I tell you I have to kill you kind of thing. So I don't want to test it.
Stay tuned. So what date did you say that launch?
It's November the 10th.
November 10th.
Yeah.
We'll stay tuned for that. One last thing before we go. I saw on a tweet that you posted something about, at Splunk conference, a disco, but it's not a normal disco, it was a silent disco. What was that all about?
Yeah, so silent disco, have you seen these before?
I wasn't at the one at Splunk Conf, but I've been to one here in Sydney.
Yeah,
and they're really weird.
Yeah, it's really strange, but it's really fun. So if you're into, kind of dancing like a disco, it's a neat concept. So what they have is kind of a fenced-off area, and in this case, there's like a big event. But to go in, the outside of this basically is fenced-in dance area, and up in the stage, there's two DJs. There's left and right, or in this case, it was blue and green. And then when you go in, they give you this set of headphones, and you put these headphones on, and there's a little switch on the side that you can choose which DJ you're listening to, blue or green. So like they're spinning different music, but the only people that can hear it are the people with the headphones on, and the headphones only work within that little confined parameter. So it's kind of fun because you'd be listening to, let's say, the blue DJ, and you're dancing, you're feeling the groove, and then you walk over and you're like, hey, there's a girl over there dancing to the blue one as well. Maybe I should go dance with her. And you kind of walk up, you start dancing. If you see her go immediately to green, you're pretty sure that she doesn't want to dance with you. Luckily, I had my wife with me, so she was obligated to dance with me on the color that I was on. So, but I saw some pretty funny experiences.
So imagine if you're watching this.
It's really weird.
You just see people with headphones dancing to silence or to background noise, dancing to...
Yeah, it's pretty great. It's it's very friendly to the environment because you're not waking up the neighbors, you're not bothering the wildlife wherever you might be. So it's pretty cool.
So when your kids turn like 17, get them a silent disco kit. Is that the tip?
Yeah, I think there's maybe I'll give away a little investment idea, but there's probably a pretty cool way to do that with the iPhones to enable silent discos with your iPhone. Might be kind of a cool idea.
That is awesome. All right, well, let's get out and build it now. Thank you, Cory Minton. It's been an absolute pleasure having you on the show today.
My pleasure.
Enjoy the rest of your trip. I hope the family enjoys the tour down under.
Yeah.
And good luck to Brent and Brian getting you onto the plot isle. I think we've covered all the good topics now. So.
Yeah, I don't know. Hopefully I can save a little more. Maybe it'll be after the 10th so we can talk more about some of that exciting stuff that Iceland's going to announce.
All right. And thank you. This has been Tech Basement, Episode 2. I'm Matt Walensky and my co-host,
Dean Jackson.
And we'll catch you on the next show. Thank you.
Thank you.